Okay, Assalamualaikum and good evening to all my students. So this is our last part, final part for the chapter 2.2. So this is all about the invariant equilibrium. Uh, this is quite complicated phases in the phase diagram. So I think in your syllabus it is more on the knowledge, and maybe I cannot promise, but maybe it is not very important that will be come out in your final exam or quiz, but I said maybe. So either way you have to study this subject about the invariant equilibrium. Okay, so let's get started. So different system have different types of alloy transformations, as stated in these slides. Invariant equilibrium involve in more than two, or specifically as in three phases that can coexist. Okay, it exists only at one temperature or at fixed temperature. Composition of three phases coexist is fixed at the point 0 degree of freedom. Okay, below are the example of alloy transformation at invariant equilibrium. There are 7 types of invariant equilibrium here. We have eutectic that we have already familiar about the eutectic that we have discussed in the previous video, and also the eutectoid. But the more complicated are the peritectic, peritectoid, metatectic, monosynthetic, syntactic. Okay, so this is the summary of the reaction and the example of the composition, and also what are the elements alloy exist in that type of invariant equilibrium. Okay, so let's get to the example here. Okay, so it has many regions compared to the phase diagram that we have learned before this. Okay, as in this example, the figure shows an incomplete copper and zinc phase diagram. Okay, identify X and Y region. This is the X and Y. So we have here as a liquid solution, and here is the solid solution for the gamma, and this is the for epsilon. Okay, so around here it will about the epsilon. Okay, and between the epsilon and liquid here we have the mixed region between the solid of epsilon and the liquid solutions, and then we get epsilon plus L. So before epsilon and Y we have intermediate region again here, so it will become the mix of gamma and epsilon. So same wise as the upper side here. So between here and liquid, so we have the region of gamma plus liquid, and then here is the delta. So this is around have more than 2. In this case we have 3. Okay, we have 3 that coexist, 3 elements that coexist in this particular region here. So what is the X and Y as in this question and example? So X is the delta. Why? Because why do we have delta here? So you can predict by your own. If here is a liquid, so this is the intermediate between this region and the liquid. So in this case it shows already the delta plus the liquid, so it means automatically acts as the delta. Okay, how about the Y region? Okay, Y region is between X and epsilon here, right? So between those solid solution, okay, so this here is delta, so this is epsilon. So the intermediate in between x here, delta, and the epsilon here, it must be the delta plus epsilon. So this is the answer for the y. Okay, so this is how I don't think you have this slide, or maybe you have. If you already have this slides in this slide in your notes, so this shows in detail to explain the answers of this question example. Okay, so let's go to the other example here. Figures shows an incomplete nickel titanium phase diagram. Okay, if you can refer the summary here between the nickel and titanium, we do not have that nickel and titanium in the summary. Okay, so the question asks you to identify A and B region. Okay, so let's predict between the A and B region. So liquid here, around here, in between beta and gamma. So beta here, beta and gamma. Okay, so for the B region, I can say that this is between the liquid. Okay, so it will be the liquid here, and also plus the beta. So the B region is can be decided as the peritectic solutions. Two-phase region consists of liquid solution and solid solutions, gamma plus liquid. Change the single phase region of solid solutions, which call the delta here. Okay, so you can study more about this if you refer to the textbooks. So once again, in the summary of subchapter 2.2, we have the summary of the terminologies here. You can find the definition of every terms in the subchapter 2.2 that you have found. Okay, so before we go to the 2.3, so this one will be learned in the next video. I will create a specific video for the 2.3 about the ferrum carbon system. Okay, so that's all for the subchapter 2.2, the final part. So in general, we have 4 parts of video for the subchapter 2.2, and I hope you all can study. And if you have a problem, you can ask me in the WhatsApp group. Okay, so assalamualaikum and good evening. Bye bye.